topic in part C, then we start part D to finish module 4, but we have some more topics left in module 5. Yeah. So you can see, near the final, we have some topics left. Yeah, but we do not have a lot of time. So I need to go a little faster. So for the part not that important, I will go a little faster. Yeah. All right. Taylor, just join us. Okay. All right. Yeah. So I will do it later after class. All right. Yeah, but today I want to do this. First, I want to give you hints to the homework assignment number 2. Yeah. But I cannot spend too much time, so I try to control. So after, if I couldn't definitely I cannot complete it. So then I will record a video to complete it. So then you watch the video for the remaining questions. I may still use the way we used the last time. Remember, if you watch the hint video, you can get 2 bonus points. Yeah, especially for the last 5 questions. Yeah. All right. So, in a video. Yeah. So after that, I need to complete part C. Then I need to start part D. Yeah. So, a lot of things. So this week I try to complete part D. So next week we only have 2 classes left, right? Yeah. So I may start module 5. Yeah, but I can only do 1 class, in module 5. Yeah. So I just try my best. Yeah. So because I need to give the last class review. Yeah. So the last class of the semester, I need to do review for the final. Okay. Yeah. So, all right. So that's the plan. Let me start. Question?
Yeah. So for the last class, you said for review. Do you mean like next Tuesday or next Thursday? If it's next Thursday.
Thursday. Next Thursday. Next Thursday. That's our last class.
Okay, so we taking a final at home or something?
Because final is another week. Next week is our regular semester. Still, regular classes. Not the final week. Final week is the 3rd week of December. 3rd week of December, that's our final week.
Okay, and that's on
yeah.
Tuesday or Thursday.
Right. Yeah, but because since you asked this question, let me quickly, because probably some students still not quite clear about the final. Let me update our final a little bit. All right, the 3rd week, the whole week, 3rd week. Yeah. So here I just look at our syllabus. All right. Here, the syllabus. All right. Yeah. Final exam. Yeah. So let me clarify. December 18th, Thursday. 18th. Yeah. So that's the Thursday of the 3rd week of December. Yeah. December 18th. Thursday at 10 o'clock, not 12:30, okay? At 10 o'clock, yeah. So you can double check. 10 to 12, 2 hours. 10, starting time, 10 o'clock, okay? Yeah.
Okay.
Yeah, just, make sure, yeah. All right.
Okay. Can you also remind us next week? Because yeah.
Right. So we have 2 weeks before the final week. We have 2 weeks regular classes, total 4 classes. All right. So the last class, that's the Thursday, December 11th. Next week, that's our review class. All right? Yeah. Okay. All right. Let me stop right here. Yeah. First, I need to, just a minute, because here I use my recording computer, so I need to recover the full screen recording. Otherwise, we have some problem. Yeah. All right. Yeah. Now let me bring up our homework assignment number 2. Let me do some hint. Yeah. All right. All right. I need to get my annotation software. Yeah. Oh, that's not right. Yeah. What's wrong? I need to bring up. So what's that? Is it this one? Yeah, right. Okay. Yeah, this one. All right. But I need to get a homework assignment number 2. This one. All right. All right. Today in class, I can only use half of the class to give you hints. Then I approximately do half of the questions. The remaining half, I will put in a video. So if you watch the video, then you claim you have watched, then you can earn 2 bonus points. All right. Yeah. So let me start. Yeah. All right. The first question, very simple. Yeah. So the first question, I do not need to. So you can do it. Yeah. You can find the formula. So in our notes, we have the formula. Yeah. All right. Yeah. So this is the hints. Okay. All right. Then, so let me see which one I need a hint. Yeah. All right. Yeah. Second, remember I did sorting for the 4-element array without any condition, and here I just add. You have this known results. So you can use this known results to help you reduce the number of comparisons. Yeah, so that is also easy. Yeah. Yeah, the third one. Yeah, I may like to explain the third one. The third one, the input is like this. Yeah. Only one inversion. So this is our input. And this question, you need to apply the standard insertion sort on this input directly. Yeah. So this question, so you need to go through the standard insertion sort on this input. Okay, all right, yeah. Insert the element one by one, then based on this condition, you count the number of comparisons. Okay, yeah. Do not apply any formula. So this one, because many students, they like to apply formulas, plug in numbers, yeah. But for this question, do not apply any formula. Yeah. Okay. Yeah. Yeah. Because our formulas typically we do best case, worst case. So we have best case, worst case formula. But this case, not the best, not the worst. Yeah. So for specific input, so you need to apply your insertion sort directly on it and count the number of comparisons. Okay? Yeah. So that's number 3. Yeah. Number four, I need to talk about the right process. Yeah, I need to explain the right process. All right? Yeah. Because many students, when I did grading before, I noticed many students did a merge sort in the wrong way. Yeah. All right? Yeah. So what's the right way? What's the wrong way? All right? Yeah. Yeah. So here, 7 elements. Yeah. Let me draw 7 element array. Yeah. 1, 2, 3, 4, 5, 6, 7. All right. And here, when we remember our merge sort, we do divide and conquer, right? Yeah. So you need to apply divide and conquer. All right. Yeah. First, divide and conquer. Yeah. 2 subarray. Yeah. This is the median. Yeah. So we split. Yeah. The median, we put it with the left subarray. So right subarray. Yeah. First split. This is the first split. Okay. All right. Second split. Second split. Second split. Second split. All right. Then third split. Third split. Third split. Third split. And no split. Yeah, because only singleton here. Okay, one element. So we just stop doing anything. Then for the merge, you do the reverse way. Yeah. So reverse your splitting order. Yeah. In a reverse order of your splitting. Okay. All right. First, we merge 2 subarrays corresponding to the third split. Yeah. All right. So merge. But when you merge, the best case formula, we apply the best case formula. Okay. Best case formula, remember the minimum of m and n, right? Yeah. Minimum of m and n. All right. So the minimum, so here, m is 1. Yeah. N is 1. Minimum, that's 1, right? Yeah. So, but when I like to use a notation, yeah, because the information we need to use, I like the parenthesis. Then the first number is number of comparisons. Minimum m and n, that's 1, right? Yeah, because m is 1, n is 1, so it's 1. But then I put a vertical bar. The second one, I need to put the data size. After the merge, what is the size of the array? That's 2. So I write it like this, okay? Yeah, because later, when we do the merge of the next step, we need to apply on the size, right? Yeah. So this is the number of comparison. We need to do the subtotal. So number of comparisons for subtotal. Okay? And this number, data size for the merge formula. Merge formula. Right? Yeah. All right. So here I just do one example. Yeah. You complete the remaining part. Okay. Each step. All right. Yeah. So the merge corresponding to split number 3. Merge corresponding to split number 3. After that, merge corresponding to the split number 2. Merge corresponding to split number 2. The last one, merge corresponding to first split. All right? Yeah. So this way I call the top down way. Yeah. Top down. Divide and conquer. So top down way. Yeah. But a common error for many students, they use the bottom up. Okay? So here I write, do not use the bottom up way. Yeah, that's a common error, bottom up way. What's that bottom up? Because many students, they feel for convenience, they use the bottom up way. Okay, so what's that bottom up way? All right. Yeah. Like this, 1, 2, 3, 7 elements. Okay? Then they start from the bottom, right? Yeah. So they merge, so they pair the elements to do the merge. Okay? All right. So then, yeah. But here it looks like you do the bottom up way the same, but later when you do for the array with different sizes, sometimes your result would be different. Okay? Yeah. Yeah. Sometimes the result could be different if you do the bottom up way. Yeah. Yeah. Yeah, you can, because if the size is 9, if you change the size to 9, then your bottom up way, you will get a different answer. Okay? Yeah. Yeah. So you merge, that. So you do not merge, right? Yeah. So then, this time you merge like this, you merge like that. Yeah, no, right? Yeah. So you can see what you will do. You will get a different answer. It's the bottom up way. Okay? Yeah. Sometimes, yeah, for this one, yeah, so you can get probably the same answer. Yeah, but for different size, you will get different answer. Okay? Yeah. All right. So that's this question. Yeah. Then, number 5, you use the same way, same as above, but with a different formula. Different formula, okay? Yeah. Different formula because you need a worst case formula. Worst case formula, that is the m plus n minus 1. Okay. All right, different formula. And here, yeah, this time, this bottom up way, yeah, you will get a different answer. Yeah, because 10 elements. Okay, yeah. So do not. Oh, all right, slow. Do not use this way. Okay, yeah. Use the top down split. Yeah. Use this top down way. Okay, yeah. Do the top down way. Yeah. All right. Yeah. So these two questions. All right. Then this question. Yeah. This question. Yeah. Similar to our insertion sort. Remember our third question. Yeah. But this time, the input is given specific input. Okay, all right. Yeah. So then you need to, yeah, all right, so to do this, first, the same top-down splits. Okay? Yeah. All right. Second, all right. Do the standard merge operation. Okay. Do the standard merge operation, because when you split, so you will see, so your data. Yeah. So when you do the merge, you need to count the number of comparisons based on the data. The current data, the data. Yeah. So apply the standard merge operation at each merge step. Okay? Each step. All right? Yeah. And let me write another one more. Yeah. Based on the current data. So the current data, because when you do the split, you have the current data, right? Yeah. Then you count the number of operations based on the current data. Yeah. Because I'm afraid some students, so they, at each merge step, they do not base on the current data. They just apply best case, worst case formula. That's wrong. Yeah. Because sometimes you do not get a best case. You do not get a worst case. So you need to count the number of comparisons based on the current data when you do the standard merge operation. That's the main point of this question. Yeah. Yeah, because based on my experience before, many students couldn't understand how to apply the standard merge sort on the concrete input data. Concrete one. Yeah. They like to apply formulas. Yeah. But here, you may not be able to apply the formulas. You need to do the counting at each step. Okay? All right? Yeah. So let me move to the next question. If you have any question, you can ask me quickly. Yeah. All right? So now I move to the next one. Number 7, yeah, so I think because we had a similar question before, right? Remember in our homework assignment number 1. So here, the question type similar to that question. In our homework question, the bottom 2, in that one, our condition is minimum. Neither the minimum, yeah, only one. That's the bottom 1, okay? That's the bottom 1. Top 2, yeah, so in that question, our version is max. That's the top 1. Yeah. So here, you use the same analysis as our previous, the old question, but you need to change these 2 places, all right? Yeah. But after that change, the next step, all right, you need to apply one of our existing results. Yeah. All right? Yeah. Yeah. So we did that question in class. We have that result. Okay? All right. So the next step, the first step, you modify. Okay? Yeah. Modify our old way in, yeah. So you can find that question. Okay? Yeah. So when you do the, first round processing, you use this way. Okay? So this is the first round processing. Yeah. Then you need a second round processing. Second round processing, you need to apply our, one of our existing results. That's number 7. Number 8, yeah, another special question. Neither the minimum, yeah. So if you look at from the bottom, yeah, this bottom, okay, yeah, all right. So not a minimum, yeah, all right, yeah. So not. Then you look at the top side, top 13. Yeah. This. No, not in top 13. Right? All right? Yeah. All right. So not in top 13, not the minimum, yeah, right? Yeah. So then the gap part. Yeah. Okay? Yeah. This is the gap. Yeah. So your solution falls. So your solution falls in this gap part. Yeah. That's the position. This is the position for your solution. All right? Yeah? Okay? Yeah. So this is the first round analysis. All right. Then the second round. Still, you need to apply one of our existing results. Okay? Yeah. So in this situation, one of our existing results. All right? Yeah. Then, number 9, number 10, let me put together, okay? So that's the last 2 questions. After that, I need to go to our normal topics. Yeah. So I leave the last 5 questions in the video. All right? Yeah. Yeah, I mean this one, a Quicksort, yeah. After the 2 classes of this week, yeah, so this one, you can do it after this week. Yeah, so this is, pretty easy. Yeah. Then I just do the last 4 questions. Last 4 questions in a video for 2 bonus points. Like we did for homework assignment number 1. Okay? Yeah. All right. Oh, I need to move up. All right. Here. All right. Yeah. So these 2 questions similar, but the only difference is the formula different. Yeah. This is the best case. The formula when you do the merge. The worst case, yeah, all right. Oh. The worst case, you just switch to this formula, m plus n minus 1. Okay? All right. The process, the same. All right. Now, but we need to merge 3 ordered arrays. Yeah, 3 ordered arrays. Okay? All right. The first array with size A, second array with size B, the third array with size C. Yeah. But when you do the merge step by step, you have different ways, right? Yeah, you have different ways. Yeah. All right. The first way, you merge A array, the size, right? Yeah. Yeah. But you get an array with the size A plus B, right? Yeah. Size. Okay? All right. So then the second, then you merge A plus B with remaining C, then you get the size, things like that, okay? Yeah. So this is method 1. Yeah. But you may have other method, right? Yeah. Like, for example, you merge A with size A, A array, C array. So you get a size A plus C. Yeah. The second, you merge A plus that C with B array. Then you get A plus B plus, yeah. The size. Here I only do the second way. But you have third way. First, you merge B and C first, right? Yeah, get a B plus C size. Then you merge B plus C with A. So then you get A plus C plus C. Okay? The 3 methods. Then you pick the best solution, because these 3 ways, 3 different ways. So you want to pick the best solution among these three different solutions. Okay, yeah, all right. So number 10, same approach. Yeah. So same process with a different formula. In each merge step. That different formula is this formula, okay? This formula, right? Yeah? All right? So, sorry. These two questions, okay? All right? Yeah, so that's the first half of the hints for homework assignment number 2. Okay, all right? Then I need to switch to our, normal content. Yeah, okay, all right? Yeah, yeah, okay, yeah. I will try to post the video tomorrow, sometime tomorrow. Okay. Yeah, all right? So now let me go to part C. First, I need to quickly complete part C. I should not spend too much time. After that, I need to start part D. Yeah. All right. Yeah. Part C, the analysis part. Yeah. Analysis part, I just give you the general idea. Okay. Yeah. So the details, so I may not spend too much time on the details. All right, yeah, here. We complete that. So we are here in this efficiency analysis, this part. Yeah. One topic, C.3. Yeah. I just need to complete the C.3 topic. All right, yeah. Do the analysis. Best case, worst case. For the merge sort, best case, worst case, quite similar. Yeah. We only need to do one analysis. All right. Yeah. So let's recall the recurrence relation. When we do the divide and conquer, yeah, on the original array, we split in the middle, right? Yeah. So the number comparison, we use this T function, represent the number of comparison. All right. Then we do even split. Yeah. So our splitting like this. Yeah. And here we use the approximation way. Yeah. Yeah. Because n/2 here we use the approximate data size. Yeah. Yeah. And for the estimate, yeah. So here we do not need to use the exact expression. Yeah. So here you can see I didn't use the floor function, seeding function, because here we use the approximate way. Yeah. Because if we use the exact way, it could be very complicated. So we want to avoid the complexity. All right? The problem. So we use the approximate way, that's much easier than the exact way. All right. Similarly, these two subproblem with the similar data size. Okay, all right. Then we have a merge step. The merge step, we need this many comparison. Here, we use n. So if some people may argue the exact number is n minus 1, right? Exact number. Yeah, yeah. But here, yeah, we use the approximate number because that minus 1, make it a little, for the exact way, we need to worry too much on the details. Yeah. So we want a simplicity. This n is much simpler than n minus 1, so we use the approximate way. Yeah. So we have this recurrence relation. Then, when we need to estimate this t function, yeah, here I use some visual way to do the estimate. Visual way, yeah. Not a rigorous analytical way. It's a visual way. All right, yeah, all right. So here, yeah, in my derivation, I consider special case. Yeah, yeah. Then the special case we can solve it explicitly. All right, yeah. That function we use a new function to represent, so we can simplify this function. Yeah, yeah. Here I describe the general idea. Okay, the details. Yeah, details. You try your best to understand. Yeah, if you cannot understand, it's not that important. Okay, all right. Yeah, because after we will introduce a new function, then we have this is our new recurrence relation. This one much easier to solve, right? Yeah, so easy. Yeah, the initial value. Yeah, so then we do the iterations. Yeah, yeah. But here there is invariant concept. Yeah, look at the sum of these two numbers. Sum of these two numbers. That's the invariant. Yeah. All right. That's the fixed number k. Yeah. So then we can keep track of, for the last equation, yeah, the size should be 1 this side, k minus 1 this side. G of 1, we have its value, right? G of 1, yeah. So we have k minus 1/2. Yeah. Then we go back, yeah. Go back, yeah. So then we can get a t function, estimated t function. Yeah. But we need to, from k, we need to use our original variable n. Yeah. Yeah. N equals 2 to the k. Yeah. So k equals log base 2 of n. Yeah. So we put it back. So t of n approximately equal to n log n. Yeah. So for the special n, we can estimate it's n log n. All right? Yeah. So yeah. So there, yeah. For the general case, yeah. General case, yeah. So this you can use as the base of your guess, right? Yeah. Yeah. So for the general case, you can make a reasonable guess like that. Yeah. But as I said, to see the general case, we have a visual way. Okay? Visual way. To see visually, to see the general case. Yeah. But this visual way, because we need to do it again in part D. Yeah. Part D, when we need to do the quicksort, we will do this visual way. Okay? So here we do not need to repeat twice, right? So I leave it in our part D analysis. We do that visual way. Yeah. Then we cover this general case at the same time. Yeah. All right? So I complete part C. Yeah. Oh, there is another topic. Yeah. So this topic, yeah, I may leave this, yeah, because this is a big question. This is a big question. Yeah. So I want to leave it in our review session. In our review for final, then I give you the answer, the formula. Okay? Yeah. Because in the final, you may have some questions you need to apply the result of this question. Yeah. All right, so I complete part C. Yeah. Then I jump to part D to give you a short introduction in today's class. Then in our Thursday's class, I try to complete the remaining part of part D. Yeah. So then this week, we finish module 4. Yeah. So next week, I can only use the first class to do a quick, quick presentation in the heap sort. There is another sort, heap sort. Okay? Yeah. In module 5. Yeah. So then last class we have to use the whole class to do the review session. Yeah. All right. Did I change the pen color? I need to change. Oh yeah, I need to change the pen color. All right. Yeah. Yeah. Introduction. Yeah. So today I try to complete. I have 15-something minutes. I try to complete the introduction part. So then Thursday, I do the Quicksort. All right. Yeah. Implementation part. Yeah. All right. So for this new sort, we need to use a different approach, a still divide and conquer approach, yeah, but we put a different emphasis. Yeah. So here you can see we emphasize overall performance. Yeah. So that's important. Yeah. So that means we do not want to control the worst case. Yeah. For the merge sort, we want to control the worst case. The worst case cannot be very bad. Yeah. The bottleneck, we want to, control the bottleneck. Yeah. Yeah. But the emphasis for this one, our main focus is on the overall performance. Yeah. So that's the average case efficiency. Yeah. All right. Yeah. So the same old problem. Yeah. We apply divide and conquer. But our way to apply divide and conquer should be completely different from our previous methods. Yeah. All right. Yeah. Yeah. We can tolerate poor worst case performance. Yeah. So the reason why we can tolerate, yeah, because the percentage is very low. Yeah. So although it could happen, yeah, but the chance the worst case could happen is very small. Yeah. Yeah. So we can take it. Yeah. Very low. Yeah. All right. Now we need to change our view on divide and conquer. Yeah. Here we use merge sort to do comparison. Yeah. In the merge sort, our divide step is very fast. Why? Because we split in the middle. Yeah. We do not need to do any comparison. We just split in the middle directly. Yeah. So that's very fast. Yeah. All right. Then the conquer is recursion. Yeah. So automatic. Yeah. So we do not need to do anything specific. Yeah. Recursion. But the combined step, you need to do relatively more work in the combined step. Big theta of k. K is the total data size. Yeah. That's the merge step. But for this new idea, yeah, we have to make some fundamental change, right? Yeah. In order to get a completely different algorithm, you have to do some fundamental change. Yeah. Right? So what's our fundamental change? So we want to make the combined step very fast. almost nothing. Okay? Yeah. You do not need to do any specific work. Okay? What you do is the minimum work. Yeah. So this big cell 1, that means you do minimum work. So what's the minimum work? We will elaborate later. Okay? Yeah. So almost nothing. Yeah. You just understand almost nothing. All right? Yeah. So then you can combine. Yeah. All right? But you have to pay somewhere else, right? Yeah. Because sorting is not easy, right? So you have to pay in some other places. Yeah. So we need to pay a lot at the device step. Yeah. We need to do a lot of work, relatively more work, in the device step. Yeah. Because in the device step, you need to target. You need to target. Oh, yeah. Target for a special structure. Special structure. Yeah. Because only when you have a special structure, then you can enjoy this easy combine step. Okay? Or we call it, yeah, easy is not a strong word here. Or I want to use a stronger word than easy, the trivial combine step. Our combine step here is trivial. Okay? Remember? Because we do almost nothing. Nothing is stronger than easy, right? So trivial combine step. All right? Yeah. But you need to do your main work at the device step to have a very special structure. Then you can enjoy the, trivial combine step. That's the new idea. Okay? Yeah. Comparing with our merge sort, that's the new idea. All right? Yeah. So that's the way we try to do our sorting in a completely different way. And we hope to get a different, get a sort with different properties. Yeah. So that's the consideration here. Okay. All right. Yeah. Yeah. Next, we need to do some analysis. Yeah. Trivial combine step, but we need to dig into it. Yeah. Under what situation we can have a trivial combine step? We need to understand. All right? Yeah. So almost do nothing in the combine step. We need to imagine for what kind of data arrangement we have this trivial combine step. We need to see some reasonable data arrangement, right? Yeah. So if you cannot envision any reasonable data arrangement for it, you don't have the target, right? You don't have the target. So then you do not know what's your target in your device step, right? Yeah. Yeah. So you need to figure it out in order to get an objective in your device step. Yeah. All right, so let's try to see that picture. Yeah. Suppose these two subarrays specific properties they should have. Yeah. When we do the combine step, so that we just put them together without extra work, just put them together directly, then we get a whole sorted array. That's our, picture in our mind. Yeah. All right? Yeah. Yeah. Before conquer, not sorted, so each one not sorted. Yeah. Then the conquer step, because we treat it as automatic, right? Recursion, automatic, yeah. So we do not need to do anything specific in the conquer part. We just assume after the conquer step, we get the first subarray sorted. We also get a second subarray sorted. Then we need to do the combine step. But in the combine step, so here you imagine, it's an ordered array, two ordered arrays. When you, so based on our merge operation, you need a lot of work to merge these two ordered arrays, right? But here we want to consider some best case. Some best case. Because we will use that best case as our target. The target for our device step. So we can target that best case. All right? Yeah? All right. So here you need to think about what do? We just connect them, put them back to back. Then they become an automatic ordered array without any further comparison. No comparison needed. We just put them together, then the whole array becomes ordered automatically. That's the ideal case. That's our target. All right? Yeah. So think about this logic. Yeah. All right. The whole array is automatically sorted after we put them back to back. All right? Yeah. That's simple. That's our trivial combine step. Yeah. But how can that happen? How can that situation happen? What kind of data requirement we need to make it happen? That's the main question. That's the key question. We need to get that. All right? Yeah. Yeah. All right. So the goal after conquer, when combine, we do nothing. All right? Yeah. So what condition we need before conquer? Yeah. Before conquer, we need some special conditions on our data. Yeah. So here we need to find that condition out. All right? Yeah. So this is the condition. Yeah. The value of any subarray should be less than or equal to the value of any element in B subarray. If you have this condition, then you put A array, B array back to back, then you get a whole array ordered automatically, right? Yeah. So that's the picture. Yeah. All right? Yeah. Yeah. So this is our target in the device step. In device step, this is our goal. We want to divide our original array in two subarrays such that the value of any element in the first subarray should be less than or equal to the value of any element in the second subarray. If we can do that, All right? Yeah. If we can do that, then we can enjoy the trivial combined step. That's the main point. Okay? Yeah. But how to do it, that's another question. Yeah. So we will solve that question later. Yeah. But we can see our target. Yeah. We can see our goal. Right? Clearly. Yeah. Yeah. All right. Yeah. So let me finalize. Yeah. So in this introduction part, let me finalize to get ready for our remaining implementation part. Yeah. All right. Yeah. So that's the goal for the device step. Yeah. Now you can see after that, you will see the most work we need to do is at a device step. Yeah. That's the main part. Yeah. All right. So for the device step, why we need to do so much work? Because we need to have this requirement. Yeah. Yeah. Into this two subarrays such that A of I less than equal to B of J. Okay? Yeah. How can you get that, right? Yeah, next question. How can you split your original array to get this? Yeah. That's a tricky technical question. Yeah. So we need to solve that technical problem in our next class. Okay? Yeah. But here, you know, that's the critical step. Yeah. Yeah. As a conclusion of our introduction part, yeah, so we get the critical problem to be solved for this quicksort. Yeah. All right? Yeah? All right? Yeah. Yeah. So that's the, introduction. All right? Yeah, so we complete that. All right, let me stop right here. Yeah, so we finish. In our Thursday's class, yeah, I will try my best, yeah, because the remaining, we have 4 topics. Yeah. So my goal, I want to complete these 4 D.2 through D.5, something, whatever. Yeah, just the whole part D in our Thursday's class. Okay? All right? All right, yeah. See you Thursday. Yeah.